Hi, yeah, this is a video I just want to do on the Unit 3. So now we know what this product is. I just want to do a video looking at this trolley. However, I want to use the power of Onshape, so the power of CAD, just to have a look at what I think is going to be some of the problems with this trolley. And also, you're doing Unit 10 at the moment, so it might be a useful thing to look at a sheet metal product, how it's put together, handles, fasteners, and those kind of things. Okay, so firstly, if we look at these parts, and now obviously we can draw these parts, and we've got a physical size and volume of these things, but we can make them a little smarter. So if I consider the wheel, for instance, if I right click on this wheel, I can actually assign a material to this wheel. I've already done it here, so it's nylon on this wheel. It has a density, it has a strength, a yield strength, etc., etc. Okay. Similarly, if I go to this bracket, I can look at the material for that, and I've already assigned it to being steel with the density and properties that steel has. So it allows me to do some other things to this. So firstly, for instance, if I select all these parts and I come down to the bottom right to the scales, it will tell me how much this will weigh. Okay, for the whole thing, I can do the same maybe with just one wheel. If I want to know how much my nylon wheel is going to weigh, it's going to weigh 221 grams. Okay, so I can start doing some interesting things. However, a lot of CAD systems will also allow you to analyze what happens to these components when you put forces into them. And this is a slightly more advanced version of Onshape, and it allows me to do some effectively finite element analysis here. So if I look at my other assembly in here, what I have is the side of the bin, and I have the bracket, a wheel, and the axle all mounted in together. And what I've done is I've put a force in here. Okay, so we have this force here, which is 90 kilograms, and that forces upwards into the wheel. So I'm going to see what happens when I do this. So I can see the stress here. So I can see these areas are very highly stressed. Some areas less so, obviously down to zero. But also I can see how things bend, how things move, the behavior of these components. Okay, so if I look at this end on, for instance, I can now see the displacement here. And because I've got this vertical force going up into the wheel, what it's done is it's twisted this bracket here. And if I animate this, okay, so we can see this bracket bend and twist. Okay, and I can tell how much it's moving. So at the top and bottom of the wheel is moving by about 1.25 millimeters. Okay, and then I can also look at something called a safety factor, which tells me if this component is going to fail. And when I get down towards 1, it means I'm at the limit. Okay, I have a safety factor of 1. This component at these places is at the limit of what it will take. Okay, so it is a very badly designed mount, and it's badly designed on purpose, so we can improve it. So what can we do to improve it? The simplest thing we can do is just to add more material. If you look what I've done here, if you look what I've done here, so I've made this bracket much bigger. It's still from steel, it's still 5 millimeters thick. However, I've put a lot more material on top of it, which will certainly withstand the vertical loads. However, if I go to displacement, I can see that it's still moving. Okay, so my maximum displacement, it's less, but it's still a fair amount, 0.8586 of a millimeter. Again, I can see now, interestingly, the bottom of the wheel is moving a lot more than the top. Okay, so it's changed the axis of the movement here. But if I go again to safety factor, okay, at least this part now, apart from these slight areas, I'm not going to worry about those areas. Okay, largely, at least this mount now doesn't look like it's going to fail. And in fact, the areas where there could be a problem is where this axle attaches to this mounting bracket. Okay, but at least I've now got a safety thing. But it's not the most elegant way of doing things. Simply adding material just makes it more expensive, it makes it heavier. Okay. If I go back to the original one and I look again at how it is moving, how it is flexing, I can see that what is happening is the top of this bracket is moving inwards and the bottom of this bracket is moving outwards. And perhaps not surprisingly, when I put a vertical load in here, it is twisting that. It's creating a torsion around this bracket and it's twisting. So what I perhaps really want to do is address this lateral movement. Okay, so as an engineer, I want to think about where's the most effective place for me to put material. And I have a third design here. And on this third design, what I've done is I've put some horizontal mounts in here, top and bottom. I put some horizontal supports in there. So I've actually used the original bracket. However, I've added these mounts in here. And as you can see, the stress has come way down, is very, very low on this bracket. But also, if I look at the displacement, so now my maximum displacement has gone down hugely, okay, because I've actually addressed the movement and the direction the forces are being applied in. My maximum movement now is a tiny amount, 0.157 of a millimeter. And if I put the wheel back in, I can see that that movement is top and bottom on the wheel. But if I animate it, again, we can see that it's a tiny amount of movement, virtually nothing in this bracket. And in fact, I had the wheel hidden because what I really want to look at is now the issue I've got is the flex in this axle. I can see that really all the movement is this axle flexing. Again, if I go to the safety factor, my mount now is 30, 40 times stronger than it needs to be. So arguably, I don't need that much material. Maybe I could make it from thinner material. Maybe I could make these smaller, put a hole in it, etc., etc. However, the area where I've got an issue with things breaking is in the end of this axle. And that's not surprising really, because what I've done is I've put a load in here, but this axle is only supported at one end. So not surprisingly, when I push it up, it's going to bend around this point. And this is where the issue is here, because this is mounted in something we call single shear. Okay, there's nothing supporting this end of the axle, so it is free to move and flex up and down. And we will come back and have a look at some other designs. So like I say, these are improvements, but they're perhaps not the most elegant design. They're not the best design. And I would like you to have a think about something called single shear and double shear. And I'll put a video on Teams. It's a short little video and it talks about this idea of single shear and double shear and how we should mount these things. Okay, so perhaps go and have a look at that video. And then we'll look again at some other designs for this trolley. But I think for the moment, issues with this bending and twisting and possibly failing are going to come up in the exam. Okay.